Okay, now let's look at finding the turning point of a quadratic formula. Okay. So far we have learned using method 1, which is completing the square. So example, we have a quadratic function x squared minus 2x minus 15. If you carry out the completing the square methodology, you will end up with x minus 1 holding bracket square minus 16. So once you have completing the square on the quadratic function, from here x minus 1 equal to 0 and x equal to 1, then this will be the x coordinate of the minimum point, and this value will be the y coordinate of the minimum point. Okay. The second method is finding the x-intercept. Okay. After you find the x-intercept, you find the midpoint of the x-intercept. Okay, this is the second method. Now what you do is find the x-intercept, put y equal to 0, and you factorize, and you end up the x-intercept is minus 3, the other one is 5. So finding the midpoint, just add them together, divide by 2, you get x equal to 1. Okay, so x equal to 1 is actually this, x equal to 1, this line here, it will become the axis of symmetry. Therefore, the coordinate at this, the x coordinate at this point is also x equal to 1. To find the y coordinate, you just take the function, the original function y, and then substitute x equal to 1. You will be able to find the y value, which is minus 16. You substitute x equal to 1. So the x equal to 1 and y equal to minus 16 is the minimum point. Okay, now I'm going to introduce the third method using quadratic formula. Okay, now using the same quadratic function, we will put y equal to 0. Basically, you are intersecting the quadratic graph with y equal to 0, which is the x-axis. Okay, now this is the same answer from here, finding the x-intercept. Okay, now let's proceed with this. Now let's say if I have y equal to minus 1, that means a line, this point here is y equal to 1. Okay, y equal to 1, sorry, y equal to minus 1. And you substitute y equal to minus 1 inside, you bring this over, plus 1, so this is minus 4. How do we find the intersecting point of this? The intersecting point between the quadratic curve and y equal to minus 1. In this case, using this, you will use the quadratic formula to find the intersecting point between the quadratic function and y equal to minus 1. Okay, that's how you get using the quadratic formula, you find the intersecting point between y equal to minus 1 and the quadratic graph. See the green area for continuation. Now, what happens if you have y equal to minus 2? When y equal to minus 2 will be another horizontal line passing through y equal to minus 2, and there to find the intersecting point, again we use when you first have to substitute minus 2 into the quadratic function. Substitute over here y equal to minus 2 this time, and you bring it over here. From here you use the quadratic formula to find the intersecting point between y equal to minus 2. Okay, for example, now let's say let's see, there's another line here. This y equal to minus 2. So using the quadratic, when you put y equal to minus 2, you bring it over here, you have a quadratic equation. So this quadratic you will find using the quadratic formula. You will find the intersecting point, which is again here another intersecting point. The quadratic formula will give you another intersecting point. Okay, next. If you continue y equal to minus 3, there is another horizontal line. Continue. A time will come when you draw the line y equal to minus 16. How to get y equal to minus 16? We are then taking the information from here as an illustration. By the time y equal to minus 16, this line only touches the quadratic function at one point. Okay? Now, when this happens, what happened to the quadratic formula? Only one point of intersection at its turning point. It means, therefore it means the part of the quadratic formula b squared minus 4ac is equal to 0. So as a result, the quadratic formula, okay, x equal to minus b plus minus this part here, square root b squared minus becomes 0. So when this horizontal line intersect with the tip or the turning point of the quadratic graph, the quadratic formula, the b squared minus 4ac becomes 0. So that means to say the intersecting point between this line y equal to minus 16 and the curve is x equal to minus b over 2a. Okay, so when this thing happens, your quadratic formula, the minus the b squared minus 4 becomes 0. So your quadratic formula, the x value is only minus b over 2a. Okay, but remember, when there is only one intersecting point, there is the time where the curve just touches y equal to minus 16. This is the intersecting point. Okay, so therefore the x value that you obtain from here, minus b over 2a, is actually the intersecting point between a horizontal line which touches the turning point. Okay, this situation happens only when the turning point touch a horizontal line. Okay, so from here we deduce that to find the coordinate of the turning point is minus b. Go back to the original. B is actually minus 2, so you substitute minus 2 over 2a is the coefficient of the x squared and 1. So here you got the x coordinate of the turning point of the quadratic graph. To find the y coordinate, you just substitute the x into the quadratic function. Okay, substitute inside, you get the y coordinate of the turning point. So in other words, to find the turning point, the coordinate of the turning point, you do not really need to go for completing the square or using the midpoint of the x-intercept. What you have to do is you just take the formula is this, minus b over 2a. Okay, minus b over 2a. So as long as you look at the quadratic function, a is 1 here, b is this value. So you just take this value and substitute into this minus b over 2a. That's it. You will get the x coordinate of the turning point. You do not need to go through this step. You do not need to go through this step. You just take minus, take the value of b, in this case minus 2, substitute inside, divided by 2, and then you take the coordinate of the coefficient of the x squared term a here, take 1. In this case 1, just substitute. Okay, so 1, 2 times 1. So you get 1. Okay. Hopefully this